Hi there, I'm Jamie Salem, and for this video reflection I'm interested in looking at my use of questioning in my classes, specifically whether the questions are really furthering the understanding of my students or if they're actually holding things back. Also looking at things like, am I giving students enough time to answer, and am I asking questions equitably, but more so really the structure of the questions and the structure of the lesson. The lesson that this is going to be working with is a lesson examining parallel lines and equations for lines, and this is really going to be working just through the warm-up and getting kids going with using point-slope form and slope-intercept form and seeing the relationships between them with some parallel lines. Let's see how this goes.
Great, and now raise your hand if you can tell me, Rudy, bro. Raise your hand if you can tell me anything in this equation, what any of these things stand for. I see Rafa, I see Chloe, I see Emma, I see Jade, I see Marcus, perhaps, Max, anybody else? What any of these things in point-slope form stand for? Rudy?
Oh, do I answer?
Marcus, we haven't heard from you a little bit. You feel like you might know? Give me one of them. What do you think one of these things might be?
I think M.
What do you think M is?
This is that. I don't know the word.
Give it to me in any words.
The slope.
The slope. That's a good word. Cool. Jade, what's another one? The point of the y-intercept? What do you mean by that? Okay. Rowan, you want to help out?
It's the y coordinate
Of what?
of heart.
Not of a heart. Y coordinate of the point. And then, Rafa, what else?
The x one is the x value of any point.
Of any point?
Of the x point. You know?
So in that case, I was really just asking some questions to establish some baseline knowledge that would help the students out with the problem that was going ahead. I asked students to raise their hand, and I gave time. I acknowledged those who had their hands up to let them know that I saw them, and also to give other students some motivation to try to get their hands up as well. And I used the opportunity to call on a couple of students, Marcus and Jade, who are often a little bit more hesitant or timid in class, because I thought it was a situation in which they could see some success early on and build some confidence moving forward. Doing so I thought worked pretty well, except it took a while. And so for those students who were right there with what those things meant, it was probably a lot of sitting, even if it was just a minute or so. That's a slow way to get things started.
So, for number 2, Rafa, what's your question?
I was asking if you wanted to like the onion or something so you know.
So in the question, what's the word that we're dealing with here?
Opposite of the slope.
The opposite of the slope. What does opposite mean?
The other
What does opposite mean in math?
value.
I don't like that question.
Is it absolute value?
Just change this.
How about this? What is the opposite of -3?
Positive.
Okay.
Oh, wait.
What is the opposite of 5?
Negative 5.
-5.
I just raised it.
Plus 5.
What is the opposite of -1?
Positive 1.
Okay. So Rob, does that help you out?
Okay. Yeah.
Yeah?
So in that case, I was really just asking some questions to establish some baseline knowledge that would help the students out with the problem that was going ahead. I asked students to raise their hand, and I gave time. I acknowledged those who had their hands up to let them know that I saw them, and also to give other students some motivation to try to get their hands up as well. And I used the opportunity to call on a couple of students, Marcus and Jade, who are often a little bit more hesitant or timid in class, because I thought it was a situation in which they could see some success early on and build some confidence moving forward. Doing so I thought worked pretty well, except it took a while. And so for those students who were right there with what those things meant, it was probably a lot of sitting, even if it was just a minute or so. That's a slow way to get things started.
And let's do the following. I'm going to call on somebody to get me started on number 1, and then we're going to go from there.
It's gonna be.
Wait a second.
It's gonna be you. It's either you or Rafa. Robert or Rafa.
Why yes?
I don't know.
Give me that.
It's gonna be London.
Jade,
Oh,
how are you getting us started on number 1? What's some important information that we can use in number 1?
You can use your point slope
Okay. What 2 things do we need in order to use point slope form? A coordinate pair, a point, and a slope, right? It's right there in the name. Great. Awesome, Jade. Thank you for getting us going. If you weren't able to do that, let's take a look at it now and see if that can help you out. Okay. Rafa, give me one of these things that we have in problem 1.
2,2.
2,2. Great. And Chloe, give me the other piece we have in problem 1.
That's not the same slope as the one on the graph.
Has to have the same slope as the line in the graph. Did you figure out what that slope was?
Yeah.
1 over 2 or
Or 1 over
1/2. 2 over 1 would be different, right, Rudy?
Up 2 over 1.
Wait, Rudy, how would a slope of 2 over 1 be different than a slope of 1 over 2? Or how would a slope of 2 be different than a slope of 1/2? What would those graphs look like?
Or 1 would be steeper.
Which one?
2 over 1, 1 over 2.
2 over 1.
Rudy, you can throw your voice so well this morning. Okay, yeah. A slope of 2 would be much steeper than a slope of 1/2, right? That would look different. Okay, so our slope is going to be... Great, we got our M. What's this going to be in our point slope form? Rock's not here. London?
That's gonna be the X.
Okay, how does that show up in our point slope form?
At the end.
Which of those pieces?
The X1.
X1, great. And Lydia, what's the 2 going to be then in our point slope form? That's going to be Y1. Awesome. Guys, once again, if we have our formula and we've identified our pieces, we can switch our brains off. All we have to do is plug in and make sure we're just plugging things in the right spot.
So in that case, I was really just asking some questions to establish some baseline knowledge that would help the students out with the problem that was going ahead. I asked students to raise their hand, and I gave time. I acknowledged those who had their hands up to let them know that I saw them, and also to give other students some motivation to try to get their hands up as well. And I used the opportunity to call on a couple of students, Marcus and Jade, who are often a little bit more hesitant or timid in class, because I thought it was a situation in which they could see some success early on and build some confidence moving forward. Doing so I thought worked pretty well, except it took a while. And so for those students who were right there with what those things meant, it was probably a lot of sitting, even if it was just a minute or so. That's a slow way to get things started.
So talk me through, what would you do?
To figure it out, right?
If these 2 equations are actually saying the same thing. If these are both 2 different equations for the same line.
Oh, I don't know.
Well, do these 2 equations look the same?
No.
Do they have anything in common?
Yeah.
What do they have in common?
So,
The slope is the same. Okay. What's different about them?
That one has y equals, that one has y minus 2.
Okay. So this one just has y equals. This one has y minus 2. What else is different about them?
why?
This one has a y-intercept and the other one doesn't.
This one tells us the y-intercept, the other one doesn't. True. In terms of the form, what else is different about these 2? What do you see in one of them that you don't see in the other? Parentheses. Can we get rid of those parentheses?
Yes.
How? we can distribute. What are we gonna get if we distribute?
Half x, so 1/2 x, and then 1, the negative 1.
Negative 1?
Yes.
So plus negative 1?
Yeah.
Sure. Okay. Is that starting to look more like our other one?
Sort of.
Okay. We got rid of the parentheses.
You just add 2 to both sides.
Okay, so Ravi, you said that the other difference is that this one still looks like y minus 2, whereas slope-intercept form just has y equals on its own.
Yeah.
So now how can we make it look like that?
Add 2.
Add 2 to each side.
You could just, cancel them out.
What would that give us?
That'll give you y equals 1/2 x plus,
What's negative 1 plus 2?
1.
1.
Yeah.
So in this last piece, we've actually moved beyond the warm-up problem, and I've asked the students how they can tell if their answer is correct. Chloe starts taking us through how we could compare the two equations. And I feel like the questions were, again, popcorning, got pretty good participation from about 5 of the students, and we're getting where we need to be. One of the problems that I have here is that this is above and beyond just the warm-up problem, and in total, this warm-up ended up taking us about 25 minutes. I feel like we got really good understanding out of it and dug a lot deeper than a lot of students would on a question like this. But it's a big time commitment, and I feel like the number of questions that I'm asking is kind of contributing to that. And I'm trying to figure out how to balance just moving past things without those small checks on understanding. And I think I could probably do a better job of just coming back around to students and doing some informal assessment of their understanding after things like the warm-up and that sort of thing to save some time. Yeah, that's one of the biggest things I struggle with. I can take any problem and ask questions about it for half hour. I could take an entire lesson on just one problem, just asking questions, asking kids to go deeper and deeper and deeper. I think there's value in that, but not at the expense of getting through the lesson that I have planned. And that's sometimes the sacrifice that ends up being made. The other thing that's interesting for me to look at, it's not necessarily about asking questions, but I'm noticing it's a lot of me up at the board. Those students who are answering questions are involved, but those who are not don't have a whole lot going on. And so I would really like to take this as an opportunity to get the students doing more instead of me interacting with the students. So those are my takeaways. This has certainly been instructive for me and enlightening, and there's been a lot of info that I actually cut out for the sake of time, but that was really helpful too. And I hope this is helpful for you to see kind of what's going on here. Thanks.